Hello, my very dear students. How are you all? My dear students, today I will teach you something very important to know about the classification of organic compounds. In the previous video lesson, I simply explained what organic compounds are, and today we will understand the main reason which becomes the reason for their classification. So, let me remind you what are organic compounds. Organic compounds are made up of carbon and hydrogen and which are derived from living sources, and they have unique properties, and altogether structurally they are called as hydrocarbons, which defines their compositions. And let me remind you, the carbon is very much unique in these compounds, and there are few exceptions which exclude carbon dioxide, carbon monoxide, carbonates, bicarbonates, and carbides from this definition. So whenever we need classification is their systematic study, and the classification is always done with some difference. So what will be the point of difference in them will become the reason for their classification. So here we begin. First we have a look on the variety. You see, the organic compounds number is very large. There are millions of compounds existing, and they all are different, they all are unique. And you see, sometimes they are made up of only carbon and hydrogen, and sometimes other elements are also present in their structure. For example, the very simple hydrocarbons are called as alkane. They consist of only carbon and hydrogen, and when they carry this OH group in them, they are called as alcohol. Having this CHO group in them, they are called as aldehydes. So you see, nitrogen can also be the part of organic compounds. So there's so many elements present in different arrangement. As you see, all these structures are open chain, but there is a variety in which closed rings of carbon atoms are present. Sometimes the ring is made up of only carbon atom, and sometimes some other element, mostly oxygen or sometimes nitrogen, is also present in making their ring structures. So why this is so, and if we study them all together, it would be a mess. So for the sake of easiness to study them in properly manner, we classify them, and when we classify them in different families. We classify them in different groups. We classify them in different homologous series. So today we will just observe why there is a need to make homologous series. Homologous series means the family of similar compounds. Now we will be observing the structures of methane, ethane, propane, and butane, just for the sake of example. And this is the homologous series of alkane. Now what are alkanes? Alkane are the most simple organic compounds which consist of only hydrogen and carbon. Okay, now we see the structure. In methane, there is only one carbon bonded to 4 hydrogen atoms. So the structural formula is C in the mid, and 4 hydrogen atoms are bonded to it. And you see, the formula is CH4. Now, if we add one more carbon into compound, there is existing another compound consists of 2 carbon atoms and 6 hydrogen atoms. You see, 2 carbon atoms are bonded to each other. When we see one more carbon is added, the structure is like this. So all the time when I see one carbon is added, two hydrogens are added. So if I add one carbon and two hydrogens, I get the other compound. And when I add one more CH2 group, I get another compound. So by adding just a CH2 group, this CH2 group is called as methylene group. So all these compounds have same chemical properties. They are following same nature of bonding. They are having the same elemental ratio of carbon and hydrogen. That is why they are classified in one family. And this family is called as homologous series. So we see the compounds having same structural features, same elements and the ratio, the elemental ratio, same chemical properties are grouped together or classified together in the same homologous series. Now we are at the safer side that we will be finding them in different families. As you see, there are many more examples here to understand that if we'll be finding only carbon-carbon single bonds and carbon-hydrogen single bonds and all single bonds are there, we will place them in alkane series. But when we will be tracing carbon-carbon double bond in the compound and carbon-hydrogen single bonds, there is another family, and that family is alkene. And all the carbon-carbon triply bonded compounds are classified in alkyne series. So this is how we have a variety. When we will be finding halogen in their structure bonded to carbon, they will be separately classified and studied as alkyl halide. And having NH2 group in them means NH2 group is bonded to carbon, they will be classified in amine group. So alcohols are all those organic compounds in which hydroxyl group is bonded to carbon atom. Similarly, we have another variety of compounds in which bivalent oxygen atom is bonded between carbon atoms, and this is ether family. So all these families are having the reason for their separate classification because of their different composition, different structural feature. And you see, when we get some special structural feature, that feature or that atom or that element or the group of atoms defines the chemical properties. So these structures are responsible for their chemistry. They make their chemical properties, they make their physical properties. That is why the classification is based on the presence of these special structural features. Now we see, I'm calling these special structural features as functional group. Now we need to highlight this. How many families? You see there's so many homologous series of organic compounds. And why they are classified separately? Because of having this special structural feature to which I'm calling as functional group. So organic compounds are classified into different homologous series based on different functional group. Now what is a functional group? Functional group is any atom or group of atom which contributes the chemical properties of that compound. So what is that atom? Why this atom or group of atoms is special? Why it is assigning or contributing or giving the chemical properties? Because of its reactivity. Reactivity means that's very functional, that works for the compound, that reacts for the compound. That is why whenever alkene undergoes reaction, its double bond behaves the whole chemistry. It performs chemical reactions. Similarly, halogens are the functional group of haloalkanes or alkyl halides because of their high reactivity, they contribute to their chemical properties. They undergo, the whole compound undergoes a chemical reaction in which the functional group plays its chemistry. And the only series in which we find no functional group is alkane, because all the bonds are single, either carbon-carbon single bonds or either carbon-hydrogen single bonds. And due to their non-polar nature, due to their saturated structure, the alkanes having no functional group. But beside them, all the organic compounds become reactive due to the presence of certain functional group. So here I wind up my speech or discussion regarding classification or the allocation of different organic compounds. How do they look like and why they are classified separately? This was the main motive of this class, and I'll be coming to you with another video in which I will be undergoing in detail how organic compounds can be named. Just follow me or just wait for my next video. Till then, Khuda Hafiz, God bless and take care.